So welcome everybody. I'm excited to present here to you today for SDS2 2022 and our new connection cubes within modeling here. So this is a really exciting new feature that we have that I think you're all going to like to help with reporting on the structural connections and help communicate with our engineers. So I'm going to go ahead and turn my webcam off here. I want us to focus on our presentation here, what we're going to show you. So I'm going to turn that off, and then we're going to do some quick introductions here. So kind of have somebody a little bit newer to SDS2 with us today. Caitlin Metcalf is with us here. She's going to help me present this to you today. So, Caitlin, why don't you go ahead and give us a little bit of background on yourself?
Thanks, David. Hi, everybody. Yeah, I'm Caitlin Metcalf. I am a licensed PE here in the state of California, where I'm located. I'm coming up on about 15 years experience in structural engineering and structural engineering software. So prior to coming to SDS2, I worked many years with RISA Tech and had a blast working with them on their software. So it's really fun to be back here with a sister company under this Nemescheck brand. After working with RISA, I went over to KPFF Consulting Engineers in their Irvine, California office, and I got a ton of wonderful experience working on projects of all different sizes, all different material types, working with all different building code jurisdictions. And it was a wonderful experience working with them at KPFF. Like I said, I worked on a ton of different projects. My favorite certainly always were the steel ground up projects. And really my favorite part of working as a structural engineer has always been the construction administration. It was a little stressful at times, but it's so wonderful to work with a great team of general contractor, the steel sub, architect, MEP engineers, and come together and find quick solutions to big problems that could be costing everyone money. So I'm honored to be able to work here with SDS2 and hopefully get in front of some of those problems a little bit earlier on and continue to try to help these teams work together, find more solutions so that everybody can work more efficiently together. It's going to be great. I'm also really looking forward to kind of following in the footsteps of David and everyone else here and building some of those personal relationships with our customers. So I do have my email shown on this slide, and I encourage anyone who would like to, please feel free to contact me, questions, suggestions, just want to say hi, please do. I'm looking forward to meeting all of you. Thanks.
All right, very good. Thank you, Caitlin. It's great to have you on board with SDS2. We're very excited to have you. So. Quick introduction on myself, David Zabka. Most of you know me from support, sales, number of different roles here. Been here for about 15 plus years now, so a lot of you know me already. Again, my contact info is down there at the bottom as well if you want to reach out to me. So, kind of our content today and the agenda here a little bit. We'll talk about what is this connection cube. We'll look at the benefits of it. We'll talk about how to add it to the model, how we produce drawings with it, how we customize reports with it, and we'll walk through a demonstration of all that as well, so you get a feel for how that actually works, what buttons to click, all that. So starting off here, what is a connection cube? So a connection cube is an SDS2 model object that will enhance the way engineers, detailers, and fabricators communicate connection related information. So the idea here is that we can start getting connection design into more engineers' hands, resulting in fewer RFIs on the detailers and fewer headaches, better drawings when they actually get to you guys, so that way that information is a bit more clear and makes your life a lot easier. The connection cube is going to encompass, or it can encompass, the entire structural node versus just simple member ends. Now, it could just be a member end if you wanted, if you needed, but generally the idea or the downfall of connection design tools today is that they don't include that entire structural node. And then as the detailing process goes on, that results in RFIs and questions and issues to you guys or for you guys as the detailers. So by doing this entire node, hopefully we can eliminate a lot of those issues for you. This is going to allow us to deliver a semi-customizable report with like optional 2D and 3D visualizations within it, and then different aspects of the design calculations output by SDS2. So what are the benefits of it? So I kind of mentioned it on the previous slide. So one of the ideas is to improve engineer-driven design. So those projects where the engineer is providing connection design, if we can start to get these tools in their hands, that's really going to improve the design versus spreadsheets or some of the simpler connection design products out there that maybe just do one member end or one connection and they don't encompass that entire node. And we want to just improve the communication between engineer and detailer fabricator, whether that's from the engineer to the detailer or from the detailer back to the engineer. Hopefully we can help improve the communication there. And it's going to help automate the drawing information related to your connections that you provide. And we could also use this to easily package up connection related RFIs. So in the past, a lot of you guys were probably, taking screenshots and pasting them into PDFs or taking different documents and kind of just stitching everything together manually to get your RFIs put together. This is really going to help make an easy RFI package. So, Caitlin, anything you would like to add to this benefits slide here? Especially, I'm curious on your thoughts, coming from the industry recently. You sat in the engineer's chair, so what's your thoughts from that side of things here?
Yeah, I think all these points are very important, and I'm excited excuse me, for when you get to show these later on in the demo. But absolutely, these are huge benefits on the engineering side, let alone when they get down the workflow and are working with the fabricator or any possible RFIs. But just from the engineer's standpoint, working with the entire 3D cube at once is something that I never had the opportunity to do before, except for with hand calcs, which were very, very time consuming and honestly didn't always catch issues like this. So to have the software encompass all the connections at one node, not just two members coming in, 2 or 3 connections, it could encompass anything perpendicular coming in, skewed, whatnot, and checking those for buildability in the shop, erectability and constructability on site, scaling these connections so that everything is very visible about how it can be built. If it can be built, is there anything clashing? That in addition to, excuse me, already really strong, full, extended engineering calculations, of course, that SDS2 does, makes this an incredibly easy tool to use that hopefully should avoid a lot of the issues that I personally saw and was guilty of when I was using oversimplified spreadsheets and hand calculations to do these designs in the field.
Okay, very good. Thank you.
Yeah.
So moving on here, how do we add these in the SDS2 model? So easiest way is by selecting your connection components, or you can select the member ends as well. So especially where you might have failed connections, or you built your own connection, or maybe it's a plugin that created the connection and you need to package that up. We can do that by selecting the connection component or the member end, and then in your contextual ribbon, you're going to have a simple connection cube add button that will figure out the extents of your connection component or your member end and add this cube appropriately. We can, once you've added it, you'll be able to, add or remove member ends or connection components to this cube in case you missed something or need to make adjustments there. Select, edit, delete, pretty much the same as any other model objects. When you know, left click selects, delete on the keyboard deletes, double click to edit, that type of thing. And then in the model tree in SDS2, we're going to see an additional view by option up top that's going to allow us to view all these connection cubes in a list on your model tree. So going to be really handy, especially when you start getting larger models where you might have a larger number of these cubes throughout. It's going to help organize that and find what you're looking for. So. And then producing drawings. So we can isolate these very similar to the way you would a member or a material in the model to add and edit any necessary views. We can optionally include a call out for the connection cubes on your erection views. There's a simple checkbox in your erection view settings there. There's a new drawing type in drawing editor called connection cube details that you're going to see, and that's where we're going to find and see the 2D drawings for these connection cubes. And then we can export that those cube details to PDF, DWG, DXF, or whatever. So then we could, you know, if the EOR is using Revit or other software to produce their construction documents, you know, this would allow them to easily link to that DWG or whatnot to get it as be a part of their construction documents. So, and then reporting. So we can customize the reports a bit for these connection cubes. And the list that I have here, these are just most of the items that are optional within there. So a combination of the different items that I have spelled out here can be included in these reports. And again, remember, we're going to walk through all this within the software so we actually see what it looks like. So that leads us to our demonstration. So let me go ahead and get SDS2 up here. I already have a model. And I'm going to kind of zoom in here a little bit. I'm going to focus in on this little joint over here, probably just this connection with that brace and that beam. You know, nothing too crazy, but there's some good stuff that we can show here. So how do I add these connection cubes? Well, the way I like to do it, like I said, we can select connection components. We can also select member ends. So I like to hit my selection filter to connection components, grab those two components, and then you're going to see in my contextual toolbar, I have the connection cube add. So as soon as I hit that, what it does, it reads those connection components, figures out the extents of those, and then adds this cube a bit further outside of those extents so that we get it sized appropriately. Now, you'll notice when I select these connection cubes that it also highlights the members that have connection components as part of that. So just another little easier indicator to kind of show us what's happening throughout this. And when I do select that connection cube, you'll notice then in my contextual ribbon, I get add components or member ends to a connection cube. So if I wanted to include this opposing connection into the web over here, and I didn't get it on my initial selection, you know, I can hit that now and pick that component or multiples, right click OK. Now when I pick that connection cube, you can see that member is also highlighted. So it made that component as a part of that. I don't want that in this example or this case. So I'm going to go ahead and remove that now. Okay, and we're back to just having the beam column brace and connection included here. Isolate this, so I can go ahead and hit the connection cube isolate here, and that's going to look almost identical to what you know, a typical SDS2 user is used to. If you were to isolate a member or isolate a material, you know, we have some preset views. So if we needed a top view or bottom view, some left, right, end views, or I can add in my own sections here and get additional views. So I might just add, maybe let's just say we want the top side view on there, so we can get something like that if we need in there as well. Okay, so that's the connection cube isolated. You'll also notice then over here on my model tree, we have connection cube under that view by pull down. And we can see I've got connection cube 1 listed in there currently. So I can double click on this to edit that. This is how I'm going to kind of customize my report. I can give it a name here. So I'm going to just go ahead and call this HSS brace at beam to column. And I'm going to ask Caitlin here a little bit. Caitlin, how do you feel? Tell me a little bit about the workflow that you took as an engineer at KPFF when you were doing this connection design. What the workflow for you guys there look
like? Certainly. Yeah, so honestly, we would, of course, lay out the structural steel and then take a look at any of the similar connections like this and try to group them together and design them based on our governing case. At KPFF, we were using spreadsheets and hand calcs. We didn't really utilize a lot of software. Some engineers had that availability, but it was something that I never really felt comfortable with, so I went ahead and did most of it manually. So I would pick something like this, like I know it's going to be a very important structural connection, especially here in California. We have seismic activity, so designing my brace like this would be really important, and I'd focus in on these guys early on, trying to size the gusset and whatnot. I would, like I mentioned, I had a few spreadsheets shared with me, but I felt it was safer to mainly stick with my own calc so that I could kind of control the design myself. So I would sketch it out to scale as best I could, run through the hand calcs out of the AISC manual, which was all good, except for it made revisions, which were inevitable, of course, quite difficult. You know, it's hard to go back through that and make edits. Oftentimes I had a lot of scribbles out on my work paper. It didn't look so clear by the 4th, 5th, 6th revision. And certainly there were things left out, such as the build-up checks and the constructability. So already leaning on software and seeing this availability in SDS2 makes me smack my head and wish that I had this capability when I was designing some of these structures as well, because it would have saved me weeks worth of time, honestly.
So I assume you typically had to take this information, and once you went through all that work, you did all the calcs, you did everything, you had to take those calculations and everything, you had to package it up, and you had to hand that off to kind of a senior engineer that you are to sign off on. Is that correct?
Yes, exactly. So there'd be a team of us working on any given project, especially one of any size, and we'd break up different elements of the design. So all of us would have to do these designs, come up with something that we felt comfortable with, and then bring it to our senior engineers. And that was kind of a precursor to the presentation of the calculations that we would bring to the city or state plan checker as well. So our first check was to bring these to our senior engineers. Now, because there were so many of us working and people working from home and whatnot, we didn't always have the ability to walk through the model with them. So we would create reports and whatnot, bring over stacks of our hand calcs, do our best to concisely explain the situation to our senior engineer, and then explain them how we approached it with our structural solution. So okay. Yeah, having this report would have been a key element in having that communication and being able to communicate my design to my senior engineer for his approval.
Sure. Okay. So based on that, then in the report options, your first step as you're packaging this up, you would probably would you include the schedule minimums or no?
Probably not. At first pass, I wouldn't include the minimums or the 2D detail. I would include the 3D detail just so it's easy for him to picture the connection. And then certainly the summary table and expanded calculations, absolutely.
Okay, perfect. So then we have just a pay or a spot here for any additional notes. This is just a free text field that you need to put anything in there. So, you know, in this particular case, I may punch in there like the location of this connection. So I'm going to say, you know, first floor framing connection, 112'0" intersection of grids D and 6. You know, could be anything in there though, just free form notes. The next thing we have is a cover sheet. So this is great because it allows you as a user to insert any kind of cover sheet. So this is kind of personalizing it and customizing it for your company. I have a cover sheet that I've just thrown together to kind of give an example here. You'll notice when I hit the open button there, no attachments found. So what we have to do with this is we first have to hit the little gear down here. So this is our attachment manager, and we can import the PDF attachments. So I have several I'm going to use here throughout this presentation. So we've got this is from a Simpson strong tie, their yield link moment connection. And then I have an RFI letterhead and what I'm calling a submittal letterhead. So could be anything, any different PDF that you would like. I'm going to attach it, and then I'm going to hit open on the cover sheet to grab the submittal letterhead. And then down below here, this list of attachments, I can come in here, I could grab maybe that Simpson strong tie, click attach, and then I can move it over here into my table of contents, and I can move that up and down to change where that goes within the report where that's inserted. This particular case, I don't want that, so I'm going to delete it from that report. Okay, I'll come back and use that again here in a few minutes. So I got my letterhead, got my list of attachments, included, kind of like Caitlin said, they probably wouldn't be doing the schedule minimums here if they were just getting approval, probably wouldn't do the 2D details, so I turn those things off. I am going to go ahead and generate this report. So our table of contents here just kind of shows us the order and the included things there. Auto view, as soon as this is created, tells it to go ahead and open that PDF for me. If I hit generate report, give it a name, pick the place I want this to output, pretty typical stuff here. I'm going to go with the name that it included there for me or gave me by default. It's going through, creating this PDF, and then I do have Bluebeam open. Once this PDF is created, it should go ahead and open that within Bluebeam. There we go. So this is the cover sheet, the PDF that I went in, I attached and included here. So I made it kind of fancy with, you know, some form fields and whatnot. So we can do just about anything in here. I don't even know what today's date is, so I'm just gonna throw something in there. And, you know, maybe this is to Caitlin, and it's from me, so I can fill that out. This is your own personalized PDF. You know, it might just be a cover sheet where you don't have anything to fill out. This is just an example that I put together. And then we get into the meat of things. So since the PDF was the first thing included, so very similar. If anybody's used the Create RFI tool in SDS2, you kind of know how to navigate around this here. Your different views should be included within that. So when I went into isolate and added those views, I should get lists of views within there based on that. And then just like the RFI, when I pick that, when I look at the 3D model tree, all my kind of metadata is attached in there also. Piece marks, welds, member sizes, material sizes, all that. Then if we scroll down, we start getting into then just design strength summaries for the members. So you remember we're now including the unity ratio within those reports. So Caitlin, another question for you. Like, how long would it take you to put together a report like this when you were at KPFF? I'm sure this was painful to do
Oh
so.
my God, yeah, 59 pages.
Yeah.
I mean, this would have taken me a week if I was working on just this project, you know, and obviously more if as the real world kicks in and other things come up and problems arise on other jobs. But yeah, as David's going through this, you can see just the level of calcs and every detailed variable is shown out here, which is phenomenal. It's exactly, you know, what I want to see as an engineer, just to check it, you know. Certainly we start by looking at that summary table up at the top, which also is phenomenal and really a great place for me to start as an engineer, a great place for me to start with the review process. But then everything that went into those calculated numbers is shown here down below. And so you can see all the input information, member sizes, element materials, you know, sizes, things like that. And then the full expanded calcs to show everything. So absolutely, this would have taken me weeks to produce. And frankly, there would have been a plethora of errors because even as you do, or especially as you do repetitive calcs by hand, there's always tons of room for human error, and you get lazier and lazier as you're doing the same thing over and over again. And spreadsheets might not hit every case, so all the personalized spreadsheets that people were using alongside me, there were always errors found in those as well. So this has the possibility to save weeks of time, if not months, in my eyes.
Awesome. Awesome. Very good. So you could see everything's bookmarked nice over here in your bookmarks, just straight out of the box, the way that that's created. So nice for navigation, getting around in that. So that's kind of your first step then as the engineer. You create this report, kind of put this all together. Then this goes to the EOR, put their stamp of approval on that, and then you've got to kind of create your construction documents, correct, Caitlin?
Exactly. Yep. Once we get the green light, it looks like all the calcs are correct. The next equally big step, if not bigger, is to create, you know, our product, our engineering product, what we're selling, which is our structural drawings. Yeah. So we need this output for these details.
Perfect. So that'll be my next step then. So if I grab that connection cube, I can hit the button up here in my contextual ribbon again, detail selected connection cubes. There is a, under my drawings ribbon, there is a detail connection cubes from list, similar to, you know, the way you might detail a bunch of members or materials within SDS2. You can hit that, pick from a list which ones you want to create. I'm just going to focus in on this one and create just this one. So I'll hit that. And in the meantime here, while that's creating that, I can come out here and hit my drawing editor to open up drawing editor, kind of show you the output there. Now, keep in mind, early stages of kind of putting this together. So it's not perfect. We can edit it just like we can any other drawing within SDS2, add information, delete information, whatever we need to do with the drawings for this. We'll also be able to add them to other drawings as job standard details. So that way we can kind of put all the information together on the sheets as we need. There we go. So you notice in here we have the connection cube details down at the bottom. We have the name. Remember, I changed the name of this to be descriptive for me. So that's what we get within this list. Say okay, and there's what we got. So the weld symbols probably could be placed a little bit better. Yes, like I said, everything's not perfect here, but just like anything else, we can make modifications, do as we need here. So whatever I might need to do, you'll notice I got my top view and then that kind of main view that I had asked for there as well. So I might get rid of some of this information. Clean it up a little bit. But again, we kind of get the idea, kind of see just the drawing creation of this alone, I imagine would save you time. So we have that, and now the other thing we can do is we may also want to include this on our erection views. So when I detail my erection views, placement views, general arrangement drawings, whatever you refer to them as, we have in the settings, so this is just going to be my first floor at 112'0". Within my settings here under the annotations, I have a checkbox to show the connection cubes. And when I detail up or create view 112'0", I'm going to make sure while that's going, I want to make sure that I save this drawing to save the changes that I made. And now when I open that 112'0" view within Drawing Editor, you'll notice I get that connection cube called out down here. It's reading that polygon from the connection cube just as it's displayed in the model to display it here for us to get that information there. So that's going to allow us to identify at what specific location these different connection cubes are at, so we know what connections to go where. So all very useful information. We can also then place that drawing if we want to place the connection cube detail. Right here, I do that as a job standard detail. You know, I could adjust the reference point in that as I see fit on the original drawing, but there we go. You know, maybe I would have had a label down there to call out which particular connection this was, but now we kind of have, see how we're putting this all together with the reporting for the engineer to get for their approval. We get the drawings for the construction documents, and we can kind of see this all coming together here for us. So, anything you want to add to any of that stuff that I mentioned there, Caitlin? Something I might have missed, or
no, I want to just reinforce the power of the output of these. I know you had mentioned that, you know, things can be modified and edited, and from an engineer's point of view, that is completely reasonable, and no doubt I would go in there and maybe modify things to match my typical drafting standards of my office anyhow. But to me, the power of these 2D details is just, of course, the ease of time saving. I can output this, make a few changes in just a few minutes, share it with my structural drafter, and we're good to go. And then also seeing it scale. I mean, again, like I said, we had, you know, the majority of our RFI issues in my history was just because we relied too much on typical details and things that we didn't check for specific job cases and the buildability, erectability, constructability issues. And so it just, again, is such an amazing time-saving tool now during the design phase, and then in the future of possibly circumventing a lot of issues, change orders, RFIs, a lot of team frustration down the line. So this output of these details to me is another immense time saver for the engineer and hopefully for the design team in all.
Okay, perfect. So that's kind of a great overview how I might use that from, again, that engineering perspective, that engineering workflow. So now I want to take another kind of approach or another look at this, and how you as a detailer might use this connection cube to just package up an RFI. So really it's the same concept. It's all pretty similar. What I might do is come up here, and as Caitlin talked about, you know, standard details, they don't always account for all the different framing situations on the project. They just slap it in there. So maybe they just slapped in a basic end plate connection and didn't consider, oh, well, there might be an opposing member to that where we have to have a safety connection, things like that. So that may prompt an RFI from the detailer back to the engineer to see if what they're doing is going to be acceptable. So I have that situation set up here. And again, what I would do is I would come in here, hit my connection components, grab the two connection components, connection cube add, it adds that connection cube, and you'll notice it's over here in the model tree. I can now double click on that and change that. So maybe this is going to be end plate safety connection. Maybe I want to include the scheduled minimums. Maybe I don't. I'm going to leave that. I'm basically just going to leave everything as is. But again, remember, you can pick and choose what you want to include there. So maybe in my additional notes, maybe this is where I'm going to pose some questions. So RFI questions, you know, end plate connections provided on construction documents don't account for safety connections. Please, maybe I'll do a couple lines here. The proposed design. Again, I can do that cover sheet. So remember, cover sheet, I imported that RFI letterhead earlier. Now, one thing I do want to point out is I went in, I used the attachment manager right here from this screen. You can also access this attachment manager on the home screen. Under utilities, there's a connection cube attachment manager, just launches that same window. So if you want to go ahead and bring in all these attachments that you feel you might be using ahead of time before you add any connection cubes, you can do that here in utilities through the connection cube attachment manager. Otherwise, this little button here on this screen is accessing that same thing, lets you do the same thing. So I get my cover sheet on there, and this time I'm including everything. So what's going to happen is, you know, since I'm including this 2D detail, I didn't tell it to create that drawing yet. When I do hit generate report, it's going to ask me to detail that up, and I'm going to say yes, so I do get that included on my report. So it details this, creates the 2D detail, and then it's just inserting it within that PDF. And I did have auto view checked on, so once it creates that PDF, it is going to open that up in Bluebeam for me. There we go. So slightly different cover sheet or letterhead there, if you will. Again, I included forms on there in the PDF to fill that information out. You can see the schedule minimum. So it is going to look at your connections to determine which schedule of minimums, because in SDS2, remember we have these schedule minimums for structural members that's going to apply to clip angles and plates. But then we also have the schedule of minimums for shear plates, which is different. It will look at that and include the appropriate schedule there. We get our 2D detail, so remember that's just straight out of the box. I didn't clean anything up there, so I included that 3D view again, so get the 3D in there, and then into the design strengths and the rest of that report within there. Now, just to pop up here, I do have additional notes included, so that comes after my design strengths and my other notes. So kind of lump the notes and conclusions down here at the bottom, and then included your additional notes that you type in that screen there. So got a nice, easy, well-packaged RFI that includes 2D information, 3D information, all the calcs and everything. From your standpoint, Caitlin, would this have sped up, helped the RFI process when you get RFIs as an engineer? I mean, what's that process look like? How would this have helped you kind of speed up the process?
Absolutely, absolutely, this would. So typically, I was used to seeing an RFI come back with like a hand sketch, or maybe even not even any images, but just written out like, hey, this connection won't work in this situation. You know, let me know an alternative, or can we use, you know, this instead of this, which was great to have some direction. But depending on where we were in the construction schedule, certainly this could be a red hot RFI where I need to drop all my other work and take a look at this now, because there's guys out on the site waiting to install this, and just money is just being flushed down the toilet. So certainly this would save a ton of time if you're presenting me with all the calculations, these wonderful images, so I know exactly what we're looking at. I know exactly what the conflict is. And then I just have to, again, kind of like I was speaking to when I, as an engineer, would present to my senior engineer, I would do the same process. I would take a look first at those summary tables, do a quick glance at the engineering design checks to make sure that everything looks passing and whatnot. If some of them look a little strange, like, well, why is this so low? When the similar check gets almost a failing, I can drill down and look at those expanded calcs. If I have revised loading, I can simply go through this and compare my revised loads to the capacities calculated here and do a real quick revision check. I would think something like this could take me maybe an hour or two to go through, whereas if I had to redo these checks myself, as like I'm used to doing in my experience, and go back to my initial model, verify the output loads, dump them into my revised hand calculation, and go through 20 pages of my own hand calc on my own, that would take me easily a week, even if I made it top priority of my to-do list. Whereas this, like I said, I think could be done in 1 to 2 hours. So certainly this would save a ton of time, and hopefully it would help everybody get the job done quicker, which is going to make everybody happy.
Awesome, very good. Well, hopefully we can just encourage people and adopt the first workflow, so we don't even have to send.
Yeah, you might not even get to this, which is phenomenal.
I mean, that's the ultimate goal. Whether sometimes adoption can be difficult for some. So I understand may not happen right away, but that's kind of the ultimate goal here. So now one other example here to give you, sometimes there's connections where you may run into a limitation with SDS2, or there's bought out items, whatever. Caitlin provided me with a good example of this, and the example for this would be the Simpson Strong Tie, their yield link moment frame. I don't have the plugin from them to create that, so I didn't create that, but I'm just going to go to a connection here and give us kind of walk through the example for this. So I like to turn my member ends on when I do something like this, so I'd probably actually have a plain end connection, and then I would have reached out to Simpson Strong Tie, would have gotten their yield link plugin for SDS2 that would have actually created the material for this connection right here in the model. And then what I can do is I can pick that member end, and then I can do the connection cube add. So it's still going to add that, even though there was no connection there. I was able to grab the end and have that included. And now I have that connection cube for that. So maybe I'm going to call this yield link. And, in this particular case, I may not be doing any of this information because it doesn't necessarily apply. Maybe I'm going to do my cover sheet. And then in my attachments, I could include the specs from the manufacturer on that. Excuse me, I got to select it, and I have to hit attach to get it in here. And then I've got to move it over into the table of contents and move that up and down where I want. So, maybe there's additional notes. So provided information from the connection manufacturer. And again, go ahead and generate this report then. This report's going to be much shorter since we didn't include the design strengths or the expanded calculations. But again, This was my cover sheet, one I put together. You can customize that, get your own company's notes. Okay, here's my additional notes. And then we have the PDF from Simpson that we've attached here with all the testing and reporting for that particular connection to back everything up. So any connection you build, any connection that's bought out, what have you, will work along with these connection cubes also. So that's kind of what we got today. So you know, before we move on to questions, and we'll answer your questions related to the connection cubes here, just kind of want to give a shout out to some of the upcoming events that we have here. So we'll be at NASCC March 23rd through 25th. That's out in Denver. We're booth 2411, so would love to see everybody there. It's been virtual for the last 2 years, so really looking forward to seeing everybody in person there. And then SDS2 Summit this fall, out down in San Antonio, right on the Riverwalk. Should be a great time. Good. That's always a good event to get information, network, all that as well. So, Caitlin, thank you for presenting with me today. I really appreciate your insight, your perspective. That was great. And then thank you to everyone that attended. You know, great to have everybody. Hope you learned a little bit. Hopefully you see the power of this. We do have email addresses, phone numbers there on the right if you need to reach out and contact us, and be happy to take any questions that you might have related to the connection cubes now. Okay, so yeah, we do have some questions that came in here during the webinar. Some good questions. We're going to try to keep it on topic related to our connection cubes here. So there are some others that are a little off topic. On those, I would definitely encourage you to please reach out to support. You've got my email, whatnot too. So shoot me an email, give us a call, whatever. So there's a couple good questions in here. So one's asking kind of about the extents of the views and how those are created. So in the webinar, you remember, so I can isolate those connection cubes and I can adjust the views for my 2D detail. So that's going to affect the creation of that 2D detail. I could adjust depth check, extend that, add views, whatnot. Right now, the size of that cube will kind of stay standard. It's based on the extents of the connection components there that I selected in modeling when I added that. And your U3D that's included in that report, if you choose it to be included, will just encompass the extents of that cube as well. So, so yeah, you can adjust the 2D views for that. The 3D model part of it is kind of standard or static at this particular time. A couple more here. So one question is about the expanded calcs. So, and if I have to use the expanded calcs with the connection cube. So the answer to that is no, you don't have to use the expanded calcs. If you remember on that screen, I had options for my design strength summaries and the option for expanded calcs. So if I just want the shortened version of the calcs, turn off the expanded calcs box there. Another question here is about Bluebeam. So do you have to have Bluebeam open before launching the detailing of the cubes? No, that's not the case. I just happened to have Bluebeam open as I was going through and demonstrating that. It's a little bit quicker than waiting for the full startup of Bluebeam. And remember, there was the auto view checkbox down at the bottom to when I do generate that, to go ahead and automatically open that up. So. Is it possible to hide the connection cube in the model? Yes, absolutely. So I think I demonstrated that. So it's in your display options, simple connection cubes checkbox over there on the right. So, yeah. And so Caitlin's kind of our one of our drivers behind all this connection cube stuff and engineering related portion of SDS2. So there are some I would say requests coming in for the connection cubes. It's great to see everybody is excited about this stuff, and we've already got our own ideas how to make it better. We're getting more ideas here already coming in, so I'm sure you're taking note of all of that, right?
Yeah, keep them coming, guys. That's great.
Yes. And yeah, we don't have a lot of questions here. We just had a few come through. So yeah, I don't know. You know, hopefully we get to see a lot of people at NASCC next week. We do have a couple of polls for you that we want to run. So we're going to run those polls just to get an idea of what you guys are what kind of tools you're using today is the first poll here. So what do you think, Caitlin? How many are going to be internal spreadsheets?
I hope hopefully, not too many, but I'm guessing number, that'll be a good chunk of them.
Yeah. Yes. So looks like just looking at it here, looks like about half of you that are voting are using external connection engineer, or I suppose that could be a connection engineer employed by your company as well. Little over a third are seeing, you know, typical default connections. Yeah. 10% are still doing hand calculations. How do you feel about that, Caitlin?
Well, of course, as a nerdy engineer, I love my hand calculations, but I realize that that's not realistic. It's not efficient for repetitive connection design. So, yeah, I'm kind of glad to see that people are more relying on using a connection engineer and default connections, because those are just more rigorous methods that are going to give you more accurate results.
Yep. Let's so here's our results on that. So, you know, we probably really need to be polling those connection engineers to figure out what they're using, because that's exactly going to be the key to you know, or one of the keys to all of this. So I believe we have a couple more polls here if people are still sticking around and want to participate in our polls and listen to my amazing commentary. So this one's just you know, what's your line of work? Are you independent detailer? Are you working for the fabricator? Are you a strictly connection design engineer that works with the detailer fabricator, or are you a engineer of record or EOR? And the responses here, I would say, are not surprising to me. We've got a majority of you are detailers and working for the fabricator. A few of you are the delegated connection design engineer, and a few EORs in here as well. So good mix. Glad to see a bit of a mix here. So
yeah, for sure. It definitely reflects what I felt like. My office didn't even consider software, so we're at an exciting point to be able to share this with other engineers and our connection design engineers.
Yeah. So is that just because they were kind of just stuck in their ways of working? Absolutely. And it just worked well for them, and they Just
I don't even, it
or
didn't
did they
even
not
work
want to
well.
invest? Sure.
It's not even that it worked well. It was just, there was just no time. Everybody was overwhelmed and really busy. So they just kept passing down, the old methods that everybody kind of knew were inefficient, but we just kept doing because it was faster than stopping and reevaluating and learning something new. So, yeah, unfortunately.
Yeah.
This is a good one.
Yeah, this is a good poll question here. So, yeah, good. I love the polls. I love to get the information, just collect the information. That it certainly always helps us also to understand better, where we can improve. So this is good stuff.
Big time, yeah.
And I think we have one final poll for us here quick. So, and then we'll let everybody go about their day.
Sounds great.
So this is I'm very curious on this one also to see how many are going to be a hand sketch.
I know.
Oh, everybody went and clicked it because I said
Yeah.
no cheating.
They're just feeding you what you want to see.
It was kind of a joke, actually.
I know. I'm glad we're not seeing a lot of responses there.
Yeah, and if you're using something else, go ahead and throw it in the questions pane and communicate what that other thing might be. Would be curious to hear about that. So, there's no more questions coming in. Final poll here. So if you've participated in the poll and want to hop off, feel free. Appreciate everybody's time and hope to see you, whether that's an ASCC or SDS2 Summit or wherever our paths may cross. So, yeah. Okay. Very good. Thank you,
Thank
Caitlin.
you, David, and thanks, everybody.